Hi everyone, and welcome to our week 3 of public health. We're going to be starting in around 3 to 4 minutes so that everyone can come in. Please don't spam the chat, but you can talk if you want before we start. Oh, for those of you guys confused about the 2 o'clock thing, I think that was just a mistake because the classes began on 2 on Saturdays, so don't worry about that. All right, some of y'all are asking questions about the math contest. Okay, honestly, I think Rich was the one who came up with the GM code name, but it's like around AMC 10. Okay, no, it's like around AMC 10 level, slightly easier. So hopefully that helps. But instead of 75 minutes, you'll only get 60 minutes. Oh, someone asked, how do you join the math tournament? Don't worry, I'll show you all about that once we start class. Okay, so we're gonna start right now. If anyone else is gonna come, we'll just let them trickle in. So today's topic is gonna be on analyzing epidemiological data. And one more thing, I think we kind of messed up on the time. It's normally supposed to be 4 o'clock, so sorry about the whole 2 o'clock thing. Okay, so before we begin going into the class topics today, I just want to go over our tournament that you guys probably received an email about. It's our first time hosting a math tournament, so hopefully we're going to be successful in it. So I was about it. Yes, you can join the math tournament for fun. So the second question I see is it like AMC 10? It's a little bit easier than AMC 10, but the timing is more strict. So instead of 25 questions in 75 minutes, it's 25 questions in 60 minutes. And we wrote all the questions ourselves. So we worked really hard on the tournament. So we hope you can all join. And also, joining the math tournament will give you points. And if you don't remember, I think we also sent out an email about the whole point system. And if you have a lot of points, you can attend our special conference seminar things. And you can also have your name displayed on the leaderboard. I believe the leaderboard is already up. Just go to kidteachkid.org and then there should be a tab on the point leaderboard. Okay, so more about this tournament. This is how you actually get to the tournament website. So you go to kidteachkid.org. And then you go to the home page. Sorry, I think the screen is lagging a lot, but we'll just let it load first. Okay, so you go to the home page here. I'm gonna refresh real quick. Okay, well, I think it's not loading, but once you go up here, there will be like this little arrow on the upper right corner. Yeah, upper right corner, and then you just click on that arrow, and then you click, and then it'll take you to this page, the 2020 Kid Teach Kids Summer Camp Math Competition page, and then you just read all these rules, etc. And then over here, you'll click Start the Test. Right now, it won't take you anywhere, but once you get into the contest time window, you can click on Start Test, and then there will be something you can download, and then there will be a timer going, so you have to submit all your answers within an hour and 30 minutes. An hour and 30 seconds. The 30 seconds is just to like make sure there's no issues when submitting and stuff. So yeah, you can start this contest anytime between 7 a.m. And then I think it ends at 11 p.m. on Sunday. So this weekend, that's when the contest will be. So hopefully you guys can all join. We're hoping for a lot of people to join. It'll be a great experience for you all. Okay, so now we're gonna start on our actual class today for public health. Okay, last week we left off on experimental studies. So if you remember what experimental studies were, they basically have you have the researcher manipulate various variables, and then after manipulating, they will see the dependent variable and how it changes with the independent variable. So that's an experimental study. But I think last week we already talked about how we can't use an experimental study in this outbreak investigation because it's unethical. The reason why it's unethical is because you can't force people to have certain potentially harmful exposures. So for example, if a restaurant was potentially harmful, you can't force people to go to this restaurant. So that's why experimental studies would be unethical in this circumstance. So instead we use something called an observational study. So like the name suggests, an observational study is when the researcher has people on their own will choose to either be exposed or not be exposed. So then technically they're not forcing people to do anything. They're just going based off of what people want to do themselves. And then after classifying these people into these groups, then they can determine the possible association. So this is why it'd be more ethical to use an observational study, because you're not forcing people to do anything. The researcher is not manipulating variables. You're just going with the flow. So you're observing, so to say. So here it says observational, no assignment, no manipulation, you observe. Okay, so let's look back on our little diagram here. We can see that on the left is experimental. We covered that last week. And this week we're going to cover all the purple, which it would be observational studies. First we're going to start off with classifying some observational studies. Okay, so look at these four boxes. The first row is one classification, and then the second row is the second classification. So let's look at the top row. Analytical studies are basically when a researcher is trying to establish a causation or association between an exposure and an outcome. So they're trying to figure out exactly what the exposure is. They're trying to establish like a cause and effect relationship or a correlation type relationship. But on the other hand, we can look at descriptive studies where their sole purpose is just to collect information. So we'll talk about both of those later. Next, we have retrospective studies and prospective studies. So retrospective studies occur when everything has already passed. So the exposure has passed, people have already gotten their disease. So at the end of everyone getting their disease, that's when the researcher looks back in time to try to compare the exposure and the disease. That's the retrospective study. As you can see, it's present to past. And on the other hand, we have prospective studies in which a researcher is going like forward in time. So first they will see they will classify people based on something, and then they will follow them across time. And then after a certain period of time, they'll compare their outcomes. So that is how we do retrospective versus prospective studies. So here it says present to future. Okay, any questions about the classifications of observational studies? Yeah, I don't see any relevant questions, so I'm gonna move on. Next we have probably the most important one of the various observational studies. The first one is cohort studies. So cohort studies you can see in this little diagram thing. So first you find a cohort of healthy subjects. Also, what a cohort means is just a fancy way of saying a group. So first you gather a group of healthy subjects, and then you classify them, and then you classify these subjects into either exposed or unexposed. And remember, you're trying to establish the association between an exposure and an outcome. So first, you have a group that's exposed, and then you have a group that's unexposed. And then you, after a certain amount of time in a prospective study, in a prospective cohort study, you'll look at the exposed subjects, and then you'll try to see who got the disease and who didn't get the disease. And similarly, you'll do the same thing in the unexposed section. Okay, let me check for questions. What studies are mostly being used now? So if you're talking about like for outbreak investigation, like COVID and stuff, they're honestly using a lot, because depending on what their goal is. So if their goal is to try to identify an exposure, they would use a cohort study or a case control study, as we'll see later. But if their goal is just to gather information, they'll just use a descriptive study or various other ways to collect data. So there's different studies used based on what their goal is, if that helps. Okay, so let me give you an example of a cohort study. So let's say you're a researcher and you want to study the relationship between smoking and lung cancer. And remember what prospective means. Prospective means you're starting from the present and then you're following them over time to the future. So first, what you would do is identify a group of smokers and non-smokers without lung cancer. So see, you have a cohort of healthy subjects, and then you separate them based on exposed and unexposed. So you identify a group of smokers, which are the exposed, and the non-smokers, which are the unexposed. And then step 2 would be follow them over time. So after a certain period of time, you would go to step 3, which means identify cases of lung cancer. So here you can see on the third column, in the exposed subjects, you would find people with cancer and people without cancer, and those subjects you would do the same thing. So that would be an example of a cohort study. And how exactly do you collect information in a cohort study? You use a table like this called the 2x2 table. Yeah, there's a lot of spam going on, so I'm gonna disable the chat. Okay, anyway, here you can see an example of a 2x2 table. Yeah, it looks like a 3x3 table, but really the only information that we're seeing is in the A, B, C, D letters, so that's why it's a 2x2 table. Okay, so as you can see in a cohort study, first you would have, you would just fill out this little graph or this little table based on, so A would be the number of people who are exposed who got the disease, B would be the number of people exposed without the disease, and so on. So that would be an example of a prospective cohort study. That is when you follow people a long time. So the second type of cohort study would be a retrospective cohort study. And if you remember from what I was saying earlier, a retrospective study is when everything has already occurred and you're looking back in time to be able to determine various associations. So here you take a large group of people and classify them as smokers and non-smokers. Notice the difference between step 1 of case 2 and step 1 of case 1. So type it in the chat and let me know what you think, like what is the difference between case 1 and case 2, the first step. Yes, you guys are getting this right for the most part. The difference is that the first group doesn't have lung cancer. So yeah, the reason behind this is in the first case, we have to track people who get it. But in the second case, we would have to already have everything already occurred. So that's why in the second group, we just take people in general, regardless of whether or not they have lung cancer. And then after you classify them as smokers versus non-smokers, then in each group of the smokers versus non-smokers, you'll go back and look, oh, how many people have lung cancer in the smoker group versus how many people have lung cancer in the non-smoker group. So notice that instead of following them over time, everything has already occurred. Okay, but you would fill out a similar 2x2 table, and we would calculate something called the relative risk. So here's the formula for the relative risk: A over A plus B divided by C over C plus D. So I think this one is missing a parentheses real quick. Hold on. Okay, that's right now. Okay, so yeah, you take divided by A plus B, and then take that number, and then you take C divided by C plus D, take those two quotients and then divide them, and then you get something called the relative risk. So here's how you interpret the relative risk. Those who are exposed were relative risk times more likely to get the disease compared to those who are not. So for example, if we get a relative risk of 5 for this study about smoking and lung cancer, then what it would mean would be those who were smoking are 5 times more likely to get lung cancer than those who did not smoke. So that is how you interpret the relative risk. And then as you can see, if you have a relative risk greater than 1, then there's a positive association. So the exposure is positively correlated with the disease, meaning that if you have the exposure, you're more likely to get the disease. If the relative risk is 1, then there is no association, meaning that it doesn't really affect anything. And then finally, if the relative risk is less than 1, it means that you are actually less likely to get the disease if you have the exposure. So it could possibly be something that could protect you from getting the disease. Okay, let me check questions real quick. Raymond asked, wouldn't retrospective be biased because the majority of people who have lung cancer be dead? That's actually a great point. And that is the reason why a lot of times researchers don't really like using retrospective when compared to prospective, but there are various advantages and disadvantages of each. There is certainly more bias in retrospective, but sometimes researchers offset that by not having to spend as much time and resources into the study. So that's why sometimes retrospective is still used. Okay. Okay, let's move on to the strengths and weaknesses of cohort studies. So as I was saying earlier, prospective cohort are more scientifically sound. So there's less bias, as Raymond was pointing out, and it can directly measure the incidence of disease onset. So you can directly track new cases, if you remember incidence and prevalence from last week. And then it allows researchers to establish the time sequence of events. So in a prospective study, you can easily tell when a person is getting the disease, that you know it's occurring after the exposure. But on the other hand, in retrospective studies, you may not be sure as to when the disease occurred relative to the exposure. So that's why it's better. And then weaknesses, it's expensive, time-consuming, not feasible for rare diseases, and a large sample size is often required. Okay, any questions about this before I move on to the next study design? Oh my God, guys, stop spamming in the Q&A. Q&A is for questions. So if you don't have questions, don't spam there. Okay, next we're going to talk about case control studies, which is the second most common type of observational study. As you can see here, case control is the opposite of cohort, because first you track people based on whether or not they have the disease. So the people who have the disease are called cases, and the people who don't have the disease are called controls. So then you go back in time to see whether or not they had the certain exposure. So let's look at an example, because that's probably the best way. We're going to use the same smoking and lung cancer example, but now we're using a case control study. So step 1 would be gather a group of people and group them into people with lung cancer versus people without lung cancer. And then step 2 would be track the rates of smoking versus non-smoking within each group. So out of all the smokers, out of all the people with lung cancer, you would ask them, did you smoke? And then out of the people who do not have lung cancer, you would ask them, did you smoke? So notice how it's going backwards. So someone want to explain to me why cohort studies cannot be prospective, only retrospective. So type it in the chat real quick. I'm going to open the chat for like a few seconds so y'all can discuss with each other. So let me know why. Oh, sorry. There should be case control. I don't know why case control study cannot be prospective, only retrospective. Okay, Chloe said because it's based on the people, because it's based on the experience of the people, and that is perfectly correct. Because you can't track people to get to whether or not they smoke after they already got lung cancer, because you're trying to look at the exposure after they got the disease. You go back in time to look at their exposure. You can't necessarily track people. Okay, that's why. So in the same way as we did for cohort, case control studies also use a 2x2 table, except now you would fill out the disease columns first, and then you would find the exposure values. Okay, but instead of relative risk, we use slide 10. Yeah, sure, I'll go back to slide 10. But I'll just explain. But instead of relative risk, we use a different measure of association in case control studies called the odds ratio. So I'm gonna go back to this slide now. So to calculate the odds ratio, you do AD divided by BC. And what this means is the odds of being exposed were odds ratio times higher than among cases than controls. So let's look at our smoking and lung cancer example again. So if the odds ratio is 5 again, then what that means is those who have lung cancer are 5 times more likely to have been smokers than those who do not have lung cancer. So notice how it's kind of inverted. Instead of going from exposure to disease, we're going from disease to exposure. And same thing with relative risk. If it's greater than 1, it's positive, no association, negative, same thing. Okay. Now we're going to move on to the strengths and weaknesses. So these are the case control study is good for rare diseases because you can track them based on disease. And then they're not that expensive or time consuming, mostly because they're retrospective. And there's no loss to follow-up. So loss to follow-up means that they quit your study. So there's no loss to follow-up because you're not tracking them in the first place. And the weakness is it cannot directly calculate the incidence. It's not very good at establishing the time sequence, and it's not as scientifically sound because it's more prone to bias, as I think Raymond was talking about earlier. Okay, now we're going to move on to a cross-sectional study. Cross-sectional study is different from the ones we talked about earlier because instead of it being analytical, cross-sectional studies are descriptive, meaning that they solely exist to collect information. So you actually assess the exposure and the outcome. I'm pausing the chat. You're assessing the exposure and the outcome simultaneously. So you're giving people a survey and then you ask them to check off like boxes as in, do you smoke? Do you have lung cancer? So you assess those simultaneously. So as you can see here, you create a questionnaire that says, are you a heavy smoker? And do you have lung cancer? And people will fill that out. So technically, that's why it's also called a survey. And notice that we can't exactly find an association with a cross-sectional study because you can't determine whether lung cancer occurred after they smoked or not. So you can only provide information about prevalence. And if you remember from last class, prevalence is the proportion of people in the population with the disease. Emily asks, isn't it a liability because people can lie? So this is not like, I guess people can lie, but I think most people don't really have any incentive to lie because I think most of the time when public health officials do this, it's going to be anonymous. So people won't exactly feel pressured to answer a certain way. So that's why it should be not that big of a deal. Okay, so strengths and weaknesses, you can just look at this real quick. I'm not going to go over it exactly every single thing, but let me know if you have a question. All right, final study we're going to talk about is the Ecological Study. And an ecological study is also a descriptive study, meaning that it's used to collect information. Here's an example of a ecological study. How do fluoride levels in municipal drinking water affect the IQ of a population? So notice that ecological studies are not trying to find information about specific individuals. Rather, it's about population. So many cities, many countries, many states, etc. So notice that it's fluoride levels in municipal drinking water, and a municipal drinking water would cover a large area, possibly a city. So that's why we're going on populations and not specific people, and that's why it would be called an ecological study. And since it's on populations, most of the time people using ecological studies would just be wanting to find a correlation instead of a causation association. And one thing to know about ecological studies is you cannot apply population level conclusions to an individual. That is called the ecological fallacy. So let's say in this study about fluoride levels in municipal drinking water, you found that more the places with higher fluoride rates in their drinking water have populations with lower IQ. So more fluoride equals lower IQ in a population. But you cannot say that a person who always drinks fluoride will be less IQ. That's not how it works. So that's basically an example of an ecological fallacy. Okay, here are some strengths and weaknesses. And for the most part, descriptive studies like ecological and cross-sectional can't even compare to analytical studies in their validity because they don't have like a certain methodology and control group and stuff. So they can't really create an association causation. They just want to collect information. Okay, let me check Q&A. What uses variables, like how heavy people smoke? I'm not entirely sure what you mean by that, but all of the tests really use variables. If you can see in these 2x2 tables, A, B, C, and D are all variables. So I'm not sure if that's what you mean, but let me know. Okay, anyway, where were we? So here we're going to talk about a refresher of our outbreak. If you're here for the past 2 classes, we were investigating an outbreak of E. coli in Seattle. This class is public health for Jake, if you didn't know that. Okay. So go ahead and read this outbreak real quick in case you forgot or you're new. So yeah, this is a refresher of our outbreak. We're going to use everything we just learned in the past few slides to discover the source of this outbreak. So let me know which type of study you think we should use in this outbreak. Type it in the chat. I'm going to open it real quick so you guys can talk amongst each other. So should we use cohort study, case control study, ecological study, or cross-sectional study? So let me know in the chat what you think. No, this is just a made-up outbreak, just so you guys can learn. Can y'all, okay, I'm seeing a lot of cohort. What else? Do you guys have any other ideas for what we should use for this outbreak? So for those of you guys who are saying cohort, tell me why you think it's cohort. Raymond said because you need a cause and effect. Well, I think I said earlier that all analytical studies can establish causation, or at least correlation. So some people are saying ecological. I see where you're going with that. So for every question that you're saying, you want to defend your answer. Okay, Emily said cohort because it's prospective. Okay, the thing with that is this outbreak is not necessarily prospective because think about it. Prospective is when you're trying to follow people over time. In this scenario, the exposure has already occurred and people have already gotten their disease. So that's why prospective would not necessarily be true. but that's a good way of thinking. Whoever is sending all those dots, please stop. So if you have other questions or like other suggestions as to what type of study we should use, please type it in the chat. I'm gonna put it to all panelists so you can tell me instead. Yeah. Okay, you know what? I'm just gonna go ahead and tell you guys the answer, that we should be using a case control study. The reason is because we know who has the disease versus who does not have the disease, but we don't necessarily know the exposure yet, because that's what we're trying to find. We're trying to find what possible place or what possible food causes the disease, but we don't know what it is, so it's hard for us to actually classify people by exposure. So that's why we would not use a cohort study. But on the other hand, we do know who has the disease and who does not have the disease. If you remember, that's what we focused all of last week on. We drew a line list, we made an epicurve, so we have a good grasp on who has the disease, and we could easily find out people who don't have the disease. So that's why we would use case control. So let's think about exactly how we could use the case control study. So some people are telling you that they ate at a restaurant called the Scrumptious Cuisine. Also, this is just a made up restaurant. Don't like actually try to Google this or anything. I literally just made this up. Okay, so this seems like a possible restaurant. Seems like a lot of people who go to the restaurant actually got the disease. So first, we will actually fill out the 77 and the 100 in our case. Oh, sorry, no. Yeah, my bad. Yeah, I'm right. So you would fill out the 77 and the 100 for E. coli. So you know that in this case, 77 people have E. coli and 100 people do not have E. coli. So now you would look at how many people ate at the Scrumptious Cuisine who have E. coli. So that would be 48, the rest would be 29. And versus the 100 people you gather who don't have E. coli, 25 ate at it, and then 75, the remaining did not. Okay, Emily's asking, are they using case control for COVID? The thing is for COVID, they're not necessarily using like, okay, this is kind of hard to explain, but they technically already know the source of the original outbreak, which would be in China, Wuhan to be more specific. So they don't necessarily need to use it now. For now, I think the focus for public health professionals is to place intervention measures. So for example, encourage people to wear masks, try to get people to stay at home, things like that. So they don't necessarily need to use case control anymore since they already know this exposure. But another reason why they may not technically use case control would be because they are not exactly sure as to who has COVID and who doesn't. Because there are a lot of asymptomatic cases, meaning that they don't show symptoms. So sometimes that would be difficult to use for case control studies, since case control relies on you knowing exactly who has the disease and who doesn't. So that's why they may not necessarily use that for COVID. But right now they're focusing mostly on getting the information out there, getting implementation measures out there. How can diseases be asymptomatic? We cover that in week 1, as in like sometimes people, like their immune system is able to overcome it enough so that they don't have symptoms. If you want to learn more about it, I think I talked about that in week 1. You can go on the slides or watch the video thing. Okay, anyway, we're going to talk about this outbreak right now. Let me check Q&A real quick. Wait, it is? Oh my god, I totally did not mean for the Scrumptious Cuisine to be a real place. No harm, like I don't mean anything bad on them. It was literally just 2 words that I made up. Okay. Anyway, so remember which measure of association we should use in case control studies. Which measure, was it odds ratio or was it relative risk? Type it in the chat if you remember. So y'all, as y'all type it in the chat, I'm gonna go back so that y'all get a refresher. Okay, the question was, which measure of association do we use in case control studies? Relative risk or odds ratio? Yeah, I'm seeing a lot of odds ratio, and that would be correct if you remember here. odds ratio, the formula is AD over BC. All right, so let's go back to our study. So let me know what the odds ratio would be in this case. If you plugged it into the formula, let me know what you think the odds ratio would be. So you can get your calculator out, do some calculations. Let me know what you think the odds ratio would be. I would prefer if you got the exact answer, because we will be using it to interpret some things. Okay, I see Brenda got the right answer. Emily did too. Yeah, Raymond is right. So for those of you guys who did not get 4.97, this is what you're supposed to. So remember, we have A would be 48, B would be 25, C would be 29, and D would be 75. So if we did AD over BC, we would do 48 times 75 divided by parentheses 25 times 29. So we would get the answer of 4.9655, something like that. So 4.97 approximately, as you can see in this slide. So what that means is the odds of eating at the scrumptious cuisine were 4.97 times as high among those who got E. coli compared to those who did not. So those who got E. coli were 4.9 or like 5 times more likely to have eaten at this place. So that's why it seems that the scrumptious cuisine is kind of shady. So that kind of gives us some basis to investigate. But we know that this is probably the source of contamination, but we don't know exactly what food is actually causing it. We can't just tell the restaurant, oh, you're done, like you can't serve anything. Instead, we should probably figure out exactly what is causing the disease to occur. So after going into the restaurant and talking with the chefs, talking with the owner and stuff, you think that there are possibly 3 different culprits, 3 possible foods that could potentially cause E. coli: romaine lettuce salad, beef hamburger, and ice cream. So these are the 3 that you think will need further investigation. Okay, any questions about what we're doing so far? Okay, I'm gonna open the chat real quick so you guys can discuss along with me. But please don't spam. If you spam, I'm gonna close it as soon as possible. Okay, so next let's look at the first possible food, romaine lettuce salad. So you gather the data here about the romaine lettuce, sorry Raymond, okay. So here's the data that you gathered. 37 is A, 9 is B, 11 is C, and 14 is D. So calculate the odds ratio for this and type it in the chat. So let me know what you guys got for the odds ratio for romaine lettuce salad. I'm seeing 5.23. I'm gonna wait for some more answers. Yeah, so you guys are basically getting it right. It's around 5.2323, something like that. Okay, Lucas says, I don't understand. Okay, let me just go over basically what we're doing real quick. So we found the 3 possible exposures that could possibly cause the E. coli. So what we are doing now is we filled out this table, and we're trying to figure out what the association between the romaine lettuce salad is and subsequent getting the E. coli. So we found the odds ratio, which in this case would be 5.23. Okay, that's enough. All right, 5.23. And so let me know what this 5.23 means. What would it mean? Like what conclusion can we draw from an odds ratio of 5.23? So type it in the chat. Please stop spamming 5.23s. Yes, it is not good, but you want to get, yes, Benjamin is correct. You are 5 times more likely to get it. Well, that's almost correct. It's basically correct, but there's a small thing that you need to correct. But you guys are basically getting the hang of it. What 5.23 means is if you are someone who has E. coli, you are 5.23 times more likely to have eaten the romaine lettuce salad. So notice that we're not saying eating the romaine lettuce salad will make you 5.23 times more likely to get the disease. We're saying that having the disease makes you, people who have the disease are 5.23 times more likely to have eaten the romaine lettuce salad. So let me know in the chat if this is shady or not shady to you, if we should investigate romaine lettuce salad or not. So Raymond is saying not good. I'm seeing a lot of shadies, which is the right answer. So even though this one seems really shady, we should probably look at the other 2 exposures as well. So the next one we have is beef hamburger. So go ahead and try to find the odds ratio for beef hamburger as well. Lucas is asking, how do you find okay, this is, all you have to do is plug this in the formula. So A is 28, B is 12, C is 20, and D is 13. So you just plug it into the formula AD over BC. So that's what you do. Okay, let's see. I'm seeing a lot of correct answers. 1.51666 is approximately correct. So somebody also type it in the chat what this number means or what it entails. Like, try to interpret this. Yeah, it is reasonably okay. There is a small positive correlation, but I want the exact interpretation. Okay, Chloe's right. You are 1.5 times as likely to get it from eating the hamburger, which is basically right. So if you have E. coli, you are 1.5 times as more likely than people who don't have E. coli to have eaten the beef hamburger. This one is not as bad as the one that we did earlier, which is romaine lettuce salad. But let me know if you think it's a little bit shady or not. It's probably okay. That's probably the good answer to go with. It's okay. It's not too bad, but it's still a little bit sus, but not really. Now let's move on to the last possible thing that could have caused it. Ice cream. So go ahead and do the same thing for ice cream. Find the odds ratio. Okay, 0.9 should be correct. So let me know what you think about ice cream. Is it good, bad, or not? So neither, let me know. So yeah, ice cream is good. It should be fine. It even is less than 1, meaning that it even exerts a little bit of a protective effect. So what it means is people who had E. coli are actually less likely to have eaten the ice cream. So ice cream is almost something that can protect you, so to say, from getting E. coli. So what is the final conclusion that you guys got from the outbreak? Which one do you think caused the outbreak of E. coli? Yes, lettuce is bad. That is the correct answer. So the romaine lettuce salad definitely caused the outbreak because the odds ratio is 5.23. That's huge. So let's look at what we can do to stop the outbreak. So let's see. Step 1, we can clean the surfaces. We want to make sure that our kitchen environment is clean and that we disinfect everything. We don't have random juices or raw meat laying around everywhere. We want to make sure that's not going on. Step 2 is we want to store food in correct temperature. So if we have ice cream, we don't want to put it in room temperature because it's obviously going to melt. We also don't want to be putting random foods like chicken and meat outside because we also want to put those in the freezer. Step 3 is we want to cook foods if possible. But obviously for salad, that's not really possible. Salad is traditionally eaten raw. But for normal foods like beef or chicken, we want to make sure we cook it to the correct temperatures. Step 4, separate foods from raw meat to prevent cross-contamination. Okay, so this is a very good point. The salad itself is not likely to be contaminated. What probably happened is that the salad was probably placed next to some chicken or some raw meat. And then the raw meat traditionally has E. coli. So possibly the juices from the meat were placed with the salad and the salad got the whole like contamination. So that's called cross-contamination, which is probably what resulted in the salads being the source of E. coli. Okay, step 4, separate, oh sorry, that already said that. Step 5 is report any possible new cases immediately. So if in this case of the outbreak, if a store or a family realized that one of their kids had E. coli, they would make sure to notify the public health officials to track them so that they can help get as much information as possible. So those are the 5 ways to prevent illnesses and outbreaks like this from going on. Okay, so we should all be glad that we finally solved this outbreak. Let's have a little recap. We spent 3 weeks on this and we're finally done. So let's recap exactly what we did from day 1. So first, we identified a cluster of cases of gastroenteritis in Seattle, Washington. So gastroenteritis is just a big, like, broad term for like foodborne illnesses that cause like infections in your stomach. So that is what we did first. And then step 2 was we decided that this is actually abnormal. There's actually way too many cases of this to be actually something normal. So we identified that it was an outbreak. And step 3 was we compared data, or we collected the data. We made a line list, if you remember that. We also created an epicurve. Yes, I am closing the chat. We also created an epicurve. And then we determined that it was a point source epicurve. And step 4 was we identified that the scrumptious cuisine is a possible contamination source. And we conducted a, wait, which Aiden do you guys want me to ban? Oh, Aiden? I only see one. Okay, I'm gonna let him stay in here. Oh, Yongli. Okay, I guess I'm banning this person then. Alright, I banned them. Yay. Okay, now let's talk about the next step. We identified the romaine lettuce salad as the source of contamination. So what we noticed was that romaine lettuce salad had an abnormally high odds ratio, so we needed to do further investigation. And finally, we implemented some control and prevention measures, as you can see in this slide, and to end this outbreak. So yay, we are finally done. I'm gonna open up the chat real quick so y'all can celebrate. Yay. Okay. We're actually a little bit early today, so get ready for next class next week where we talk about COVID-19 and how to create your own initiative. So any questions about any part of this outbreak at all? E. coli is definitely real, but this outbreak is not real. I made it up for, stop spamming the Discord thing, Ricky. Any questions? Oh, why are kids and teens the only victims of this type of E. coli? That's a great question. It is possible that the scrumptious cuisine is a place for kids to like eat. Mostly, possibly it's like a restaurant for kids and teens, or maybe they held a party one day and that was the type of food, like a party for kids and teens, and they ordered food from the scrumptious cuisine. So those are all possible reasons as to why kids and teens are the only victims of this type of E. coli. Any other questions about anything else in this outbreak? I will be happy to answer them. Oh yeah, and just to make sure, just so you guys are clear, this outbreak is not a real outbreak. I basically made it up. Like even all the data and stuff, I just made that up to help you guys out with understanding. And also, I just wanted to talk about, there's a lot of things that I did not cover in detail in this entire outbreak investigation. So if you want to learn more in detail about this stuff in here, I think my book, okay, no, I know my book covers the exact same outbreak investigation. Yeah, Henry, I'm kicking you out too. Sorry, man. Hold on, where are you? Wait, where is he? Okay, I see him. All right, he's gone. Okay, anyway, as I was talking about, if you want to learn more in detail, like more detail in every single step of the way, my book covers it in much more detail than I talked about it in class. But anyway, any other questions about any part of this outbreak before we move on to the last or the next class, which would be bio, if you're staying? Okay, thank you guys all for coming to this session of public health. I really enjoyed going over this entire outbreak investigation with you guys. Hopefully I gave you more insight as to how outbreaks are conducted and how epidemiologists do their thing. Next, I'm really excited for next week because next week we're going to be talking about COVID-19 and how to create your own initiative. So by own initiative, what I mean is you can create your own like software or your own organization or even write your own book like I did. So I'm going to be talking all about that and just about the new like stuff going on in our world today. So hopefully you guys can join me in next week's session as well. So yeah, I'm gonna be seeing you guys in a few minutes for biology. So hopefully you guys enjoy that.